Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of October, I'm going to be uploading 2 videos every day. One that's going to be very easy or easy difficulty, and one that's going to be average, hard, or very hard. And this is today's average puzzle. Today's puzzle is called Dutch Flatmates Dutch Flatmates Entropic Whispers by GDC. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 in every row, every column, and every box. Dutch flatmates. All fives in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So if there's a 5, say this was a 5, it would either have to have a 1 above it or a 9 below it, or both, but it doesn't have to have both. And that's throughout the grid. Entropic whispers. If 2 digits are 1 or 2 steps apart on an entropic whisper line, their difference is 3 or more. So I assume these are all entropic whisper lines. So for example, if row 4, column 4, is a 4, the 4 surrounding cells on the line, that are 1 or 2 steps away, so on the line, these 4 cells could not be from 2, 3, 4, 5, or 6. Their difference is 3 or more. So all 4 of those, interesting, have to be at least 3 away. And those are all the rules. If you want to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so that entropic line, that's very interesting. They must be at least 3 away. The four cells, so 1 or 2 steps away from it, must be at least 3 or more away. What does that mean, essentially? So say this was a 4, right? If this is a 4, this cannot be 2, 4, 5, 6, right? So it would have to be 1, 7, 8. Oh, wow. It gives you everything there that has to be. So if you have 5 that see each other, excuse me. If you have 5 that see each other, right? So say it was 9, right? I guess it could be a lot. That means it has to have a distinct set? No, it doesn't necessarily. If it's anywhere from 3 to 7, it has to have a distinct set, right? So if this is 3, it cannot be 1, 2, 3, 4, 5. It has to be 3, 6, 7, 8, 9. One or 2 steps away, right? This is an interesting rule set. I've never run into it, and I'm not sure what the implications are. So, yeah, if any, so okay, this sees all 5 in the box. This sees 5 in the box. This sees, okay, let's mark which ones see 5 in the box. All 5 of these C5 in the box. This does not, because it has 2. So all of these, if they had a 3 through 7, would have to necessarily you know exactly what the ones surrounding it have to be. Give it if you have the number from 3 to 7. What does that mean? So, okay, what about the ends? Say you have a 1. A 1 could be next to 4, 5, 6, 7, 8, 9. A 9 could be next to 1, 2, 3, 4, 5, 6. A 2 could be next to 5, 6, 7, 8, 9. An 8 can be next to 1, 2, 3, 4, 5. Okay. This does not see all 5. This does not see all 5. I mean, they all don't see each other, shall we say. I think this would probably be the easiest, because this probably has the most constraints. Interesting. Okay. Oh, that's interesting. So what happens? Okay, let's just go along with 1, right? This is 1. Let's say it's 1, right? That would mean this would have to be 4, 5, 6, 7. Okay, 1's probably the hardest. Let's just try. Let's try. Oh, let's try middle. Actually, say it's 4. That means this could be 1 or 7. 1 or 7, 8, 9. Say it's a 1. Okay, if this is 4 and this is 1, this would also have to be 7, 8, 9, because it would have to be 3 different from that and 3 different from that. Oh, that's interesting. Entropic whispers. So that means, yeah, interesting. It has to be a separate entropy one, right? So does that actually fit then? An entropic line? I think it does, right? It's just an even greater constraint than an entropic line. Yeah, I think that's the case. This is an entropic line because this has to be 3 different from that, and this has to be 3 different from that and that. Then this has to be 3 different from that and that. This has to be 3 different from that and that, which have to be 3 different from each other. So this has to be this is essentially an entropic line, but with a greater constraint. Interesting. So I guess let's do orange, pink, and yellow. So then this would be orange, pink, and yellow. This would be orange, pink, and yellow. This would be orange, pink, and yellow. You have orange, pink, and yellow. Aha. Orange, pink, and yellow. So this is just like an entropic line. It's just that there's more constraints to it. Right? Because if this was part of 1, 2, or 3, neither of these can be 1, 2, or 3. But then one of them has to be 4, 5, or 6, or 7, 8, or 9. If it's 7, 8, or 9, that has to be 4, 5, or 6 because it cannot be 1, 2, or 3, right? Yeah, so this is a greater constraint. So therefore, none of the yellows can be here. So, and this is 1 yellow, which means this has to have 2 yellows on it. So this is pink or orange. These are pink or orange. And in fact, this has to be pink and orange, which means this has to be yellow. This has to be yellow. This has to be yellow. So this can't be yellow. This has to be yellow. This is pink or orange. This is pink or orange. This is pink or orange. So this is pink, yellow, or orange. There's one more yellow here. Okay, so this has all three again. So this is pink or orange. 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 Interesting. Okay. There's two orange here. So this is pink, so this has to be yellow. Ah, so this is yellow and yellow. So all of this is pink and orange. So this is yellow and yellow. This is yellow and yellow. This is the same as this. Okay, so for these, let's make them different colors. So this is the same as this. So 1, 2, 3, which is different from that. So this is yellow and yellow. This, let's say it's gray. This has to be gray. This is dark. So we got dark, 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 dark. So this is gray, and this is dark. So these are both dark, which means none of these are dark. So this is yellow and gray. This is yellow and gray. And or gray, right? One of these is. You don't know what that is. Okay. This is 3 of each color. This is 2 different colors. I don't know if it's yellow or not. This is one set of gray, yellow, and dark, and black. This can't be yellow. So this is gray or black. This is orange. Huh. Okay. Interesting. Okay, we got also the Dutch flatmates too. So 5 has to be one of these, right? Can this be 5? Yeah, I guess. I mean, they both fit. Can this be 5? So we got the entropic lines. So this cannot be 5. I guess it could be. That could be 1, right? It just can't be 3 in a row, essentially is what it is. Oh, actually, that is a good point. If one of these is 5, it cannot be this one. It cannot be this one. So this one would have to be 5 if it's in the bottom row, and then this would have to be 1. So this would be 5, 4, 6. This would be 1. That seems plausible. Okay, so if there's any of this is 5, these are not 3 away, so it can't be 5, 1 or 9. So say this was a 5 then. This would be 4 and 6. This would be 4 and 6. This would have to be 1. So this would have to be 2 and 3. And this would be 7, 8, or 9. This would be 4, 5, or 6. So 5, 1. This is 7, 8, or 9. This is one of this 2 or 3. So this would have to be 6. This would have to be 4. This would have to be 6. So this would have to be 9. 2 or 3. So this cannot be 4. Could be 5 or 6. This has to be then 8. This would be 7. Which does not work. So that cannot be 5 cannot be on the bottom row. We know that for certain. What if 5 is here, right? Then this cannot be 9, so this would have to be 1. This would have to be 5. So then this would have to be 1. So then this would be 2 or 3. This is 2 or 3. This is 2 or 3. 4, 6, 4, 6. This would be 7, 8, 9. 7, 8, 9. So this cannot be 7. This cannot be 4, because if that's 4, this would have to be, it can't be 2 or 3. So this has to be 6. This is 4, which makes that 9. This is 8. This is 7. So this is 4, but that doesn't work because of that. So that cannot be 5. So we've eliminated 5 from the bottom row and here. What about 5 here? This can't be 9, so this has to be 1 again. This would be 4, 6. This would be 4, 6. 7, 8, 9. 7, 8, 9. 7, 8, 9. 7, 8, 9. This is 2 or 3. This is 2 or 3. So this can't be 7. This can't be 7. This would have to be 6. This would be 4. Right, because this has to be greater than 2 or 3. So this would be 9. This is 2 or 3. So this looks like it's possible. 2 or 3, 2 or 3. Yeah, this could be 7, 8, or 9. This is 8 or 9. So this would be 7 and 8. This would be 4, 5, and 6. So this cannot be 6. This would be 1, 2, or 3. This would be 4, 5, or 6. So this can't be 6. This is 4, 5. This is 1, 2, 3. This is 1, 2, 3. This is 4, 5, 6. 4, 5, 6. This would be 9. Oh, this can't be 4. So this would have to be 5. So this would be 2. This would be 3. This would be 8. Then this would be 7. This would have to be 4. No 4, no 4. So this would have to be 1. No 1, no 1. This sees both 5 and 6, so this would have to be 2. This would be 3. So this all looks valid. This all looks valid. Okay, so the 5 could be in the middle. Yeah, I'm not... Right now, I don't have any intuitions about these type of lines. It's interesting, but... So what if that's 5? Either this could be 1 or this could be 9. So say this is 9. Well, yeah, it would have to... Okay, so then... This would have to be 7, 8, 9. This would be 7, 8, 9. This would be 7, 8, 9. This would be 1, 2, 3, 1, 2, 3, 1, 2, 3. So these would be 4, 6. This would be 7, 8, or 9. 4 and 6. So this would be... This sees both of these. So this would have to be 1. This cannot be 1. This cannot be 1. This sees that one, so it cannot be 6. 4. So this is 6. This is 4. This would have to be 1. This cannot be 7. This would have to be 2. Oh, 2 and 3 does not work. So that... Interesting. That pattern doesn't seem to work. Well, maybe just in this specific set. Yeah, because if this is 5, that forces this to be 1, 2, and this would have to be 3. But then this would see both of these, right? And that cannot be difference of 3 to 4 to 6. So this cannot be 5. This 5 seems to work. What about this being 5? If this is 5... This is 4 and 6. This is 4 and 6. So if this is 5, this would be 1, 2, 3. This would be 7, 8, and 9. So if this is 5, this would have to be 1, 2, or 3. This would be 1, 2, or 3. This would be 1, 2, or 3. These would have to be 4 and 6. But, okay, now this one sees both of them. So this one would have to be 1. So this cannot be 1. This would have to be 7, 8, and 9. This is 1, 2, or 3. So that's 1 or 2. This is 2 away, so this would have to be 2. This would have to be 2. This would be 3. So this would have to be 6, and this would be 4, which does not work. Because a 4 would be in between, right? So that does not work. Okay, so there's definitely a pattern here. I just don't quite see it. I mean, I see it. I just don't know if how applicable that is, right? Say this is 5. Okay, then we have this is 4 and 6. This is 4 and 6. So this sees both of these. So it sees that. That's 1 or 2. That's 1 or 2. This has to be 3, which means this is 6. This is 4. This is 1. This is 2. So this has to be 9. This has to be 9. This has to be 8. This is 7. So this is 8. This would have to be 1. So far, this is all looking fine. So this could be 5. So either of these two being... Oh, wait. Wait, what? No, I think I'm... Wait, how did I mess that up? Okay, this is 5 is 5. That's the only one we found so far. Say this is 5. Yeah, okay, this becomes 1, 2, 3. This is 7, 8, 9, so that's 8 or 9. This has to be 2 away, so that's 8 or 9. This is 1, 2, or 3. This is 4 or 6. This is 4 or 6. This sees 5. Okay, we don't know. So this is 7, which means this has to be 4 because it has to be 2 away. This is 6. So since this is 6, this has to be 3 away, so that's a 9. This is 8. Okay, so this all looks kosher. This has to be 1. This has to be 1. This has to be 2 then. This is 3. Okay, so yeah, opposite. So this would have to be 9. Okay, so 5 is possible here, right? Okay. So if this is 5, now this is the interesting one. This could be orange or pink, right? If it's pink, then this could be the one, right? Say it's pink. So that'd be 1. Oh, which doesn't work. So say this is pink. Oh, well, actually, no. Okay, so this would be 1, 2, 3. This would be 1, 2, 3. So this would have to be 2. This is 2 away, so that would have to be 1. This is 3. This is 4, 6. This is 4, 6. So this would have to be 6. And that would be 4, but that does not work. Okay, so the 5 cannot go from the pink on the top. It can't be 1. So what if this is 9? These are both 7 and 8. Therefore, this is 8 because it's 2 away. This is 2 steps away. This is 7. This is 4 and 6. So this is 4. This is 6. This would have to be 1. This would have to be 1. This would have to be 4. This is 2, 3. This is 2, 3. These are 2, 3. Ah, okay. I'm starting to see a pattern here. Right. So if this, say, so 5 has to be one of these two right now. We've noticed from just going through. So if this is 5, the pink is 1, 2, or 3. If this is 5, the yellow is 1, 2, or 3. Okay, so let's go through these possibilities. If this is 5, this has to be 1. So if this is 5, this has to be 1. This is 2 or 3, so this is 2 away, so this is 2. This is 3. This 3 means this has to be 6. Oh, this doesn't work. Wait, why did I think that that would work? Was it a different one? Okay. Anyways. Say, okay, this can't be 5 because that can't be 1 in the same entropy. This can't be 5 because this can't be 1 in the same entropy. Was it this one? We tried this as 5, so that would have to be 1. These would be 2 and 3. This would be 7, 8, 9. This is 4 and 6. So this is 4 and 6. So this cannot be 4 because it's 1 away from 2. So it has to be 6 here. Forces that to be 9. So this has to be 8. This has to be 7. This has to be 4. This is 6. But then you have 2 and 3. So that can't be 5. Maybe I just messed up. Okay, so I guess there's one. So this is 5. That has to be 1 because this can't be 9. Therefore this is 2 or 3, so that's 2. This is 7, 8, 9, so this is 8 or 9. Okay, so this is 3, which forces this to be 6 and that to be 6. So this is 4. This has to be 9 then, so that has to be 8. And this is 7, but this is 2 away from 6, so that does not work. I'm not sure. I get sort of the general idea of how it works, but anyway. So this is 5. This cannot be 9, so this has to be 1. Which means this is 2 or 3. This is 2 or 3. That's 2 away, so this has to be 2. This is 3. But the problem is this is 4 and 6, and the 3 sees both. So this cannot be 5. If this is 5, this has to be... Oh, maybe this was it. This has to be 1, 2, 3. This is 7, 8, or 9. So this is 4 and 6. This is 1, 2, or 3. This is 7, 8, or 9. This can't be 7. This is 1, 2, or 3. So this sees 2 out of 1, 2, or 3. So this cannot be 4. So this has to be 6. This is 4. This has to be 1. This is 5. It cannot be 3. So this is 1 or 2. This is 3. And 3 and 4 does not work. Maybe I just messed up. Okay, so that can't be 5. So we're going just through everything, right? This is, if this is 5, this is 1, 2, or 3. This is 7, 8, or 9. So this is 7, 8, or 9. This can't be 7. This is 1, 2, or 3. Can't be 3. This is 1 or 2. 1 or 2. This 7, 8, 9 works here. This is 4, 6. This is 4, 6. This has to be 1 because it sees both 4 and 6s. So this is 2. This has to be 6. This is 4. But then this has to be 3. So then this... Okay. Yeah, so it's like... And we tried this one being 5. If this is 5, this could be 1, and then this one of these would be 1. So this would have to be 2. This can't be 3, so this would be 1. This would be 3. So this would be 4 and 6. So this would have to be 6. This would have to be 4. But then 4 and 3 are next to each other, so that's not possible. Okay. So then we know which one's 5. So then all the pinks are the middle. All the yellows are low. Wait, why? Oh, interesting. And all the greens, or all the oranges are high. So we know this has to be 5. We got 1, 2, 3, 1, 2, 3. These are 1, 2, 3, 1, 2, 3. 4, 5, 6, 4, 5, 6. So this sees 2, so this cannot be 4. This sees 2, so it cannot be 4. Therefore, this is 4. This is 7, 8, or 9. This is 7, 8, or 9. So it sees both of these. So this is 8 or 9, 8 or 9. This is 7. This is 1, 2, or 3. This has to be the 4. This is 6. This is 1, 2, or 3. This is 1, 2, or 3. So this has to be 1. So this becomes 2 and 3. So this is 2 away from 5. So this is 2. This is 3. So therefore this is 1. So 2 and 3. So this is 1, which means this has to be 6. So this, because this is 2 away from both of them. So this is 5. This has to be 9. This has to be 9. So this is 8. This can't be 1. Okay. So this is 1, 2, or 3. This is 1, 2, or 3. Oh, okay. So this is 2. This is 1 or 3. This is 1 or 3. They could be the same one. Right here. So this is 9. This has to be 8, and this is 7. This 4, this is 2, this is 3. Right, so this is 3 away from all of these. So this is 3 away from 4 and 1. This is 3 away from 7, 1, 4, 8. This is 3 away from 4, 7, 8, and 5. This is 4 away from 1, 4, 2, 5. Yeah, it seems fine. Okay, so this is 2 or 3. So this cannot be blue. This has to be red or green. We don't know which. This could be blue or this could be blue, right? We have the 1. The 1 is one of these. This cannot be 1, 2, or 3, so this is also red or green. So we have, this has to have an 8, and we have 4, 6, or 7 with it. So this is 4, 6, or 7. This can't be 4. This is 6 or 7. So one of these one of these is 4 and one of them is 8 at least. The problem is 6 cannot be next to either. So say this was 6, right? If one of these is 6, that means it could not be next to 4 and 8. So neither of these could be 4. It can't be next to any of them. So this can't be 6, period. So one of these has to be 4. So this can't be 4. And it's 4 with either 7 or 8. And 4 being here means this has to be 1. And this has to be 1. So one of these is 4. And you have a 7, 8 next to it. This is 1. This is 2. There cannot be a 4 here. There cannot be a 4 here. Okay, so let's... What are the possibilities here? So this is 4... Oops. This is 4, 5, 6, 8, and 9. So no 6, no 4, 9, no 5, 8. This can't be 4. This can't be 4. So this is 5, 6, 7, 8, 9. No 9. Can this be 6? No. If this was 6, this would have to be 7 or 8. And so this cannot be 6. This is either 5. So this is 5, 6, 7, 8, 9. Can't be 9. 5, 6, 7, 8. So it could be 7 or 8, in which case this is 5. Cannot be 6. We know 5 is here. Because if this was 6, that can't be 9. And that can't be 6 anyways, because it would be 7 or 8. Interesting limitations. So this is also 5, 6, 8, or 9. One of these is 4. If this is 4, this cannot be 6. If this is 6, this would have to be 7 or 8. If this is 6, that could be 4. Then this could be 9. So this could be 5. This could be 8 and 9, right? 8 is here, so this can't be 8. Oh, okay, so 9 is here. So we know 9... Oh, we already knew that. 9 was here anyways. So it's 5 or 6 here. It's 4 here. Okay, so this is 1, 4, 5, 7, 8. So no 1 and 8, no 1, 4, or 7. This is 5 or 8. This is 2, 3, 4, 6, 8. So no 4, no 6 or 8. So this is 2, 3, or 4. So this is 2, 3, 5, 6, 7, 9. No 6 or 9. No 7, 9. Okay. Interesting. So we know the 1 has to be here. The 2 is one of those two. 3, we don't know. Five, 6, 9, okay. So this is 2 or 3 or 5 or 6. So this is low or medium. which means this is low or medium, which means, okay. So let's just make it, I guess, orange. So this is orange, this is orange, this can't be orange. Orange, these can't be orange. This is orange. So this can't be 8. This is 1, 2, 3, 4, 5, 6. No 2 or 4. 1, 2, 3, 4, 5, 6. We're just gonna go in order: yellow, pink, yellow, pink, yellow, pink, and this is yellow. Aha! So that's all the yellows. Oh, this has to be 9. Okay, so we have to remember the entropy thing, right? So this is 9, which means this can't be 9. This can't be 9. So the 2 can only be here now, right? 5 has to be below a 9. This could be 5. Can that be 5? No, because there's no 1 possible. So this can't be 5. This can't be 5 because a 9 cannot be below. So we know the 5 is here. So this can't be 5. We know the 5 is here. So the 9 has to be directly below it. So this cannot be a 5. And this cannot be a 9. So the 9 and the 5 are together because the 1 has to be here. So this could be 5 or that could be 5. This cannot be 5. This cannot be 5. Because if this is 5, the 9 cannot be low and the 1 cannot be above. If this is 5, the 1 cannot be above and the 9 cannot be low. So 5 is here, which means this can't be 5. So this is 8. So this has to be the 5. So this is 1, 4, 7. This can't be 8. So 6 is here, which means this is 5, 9. So this can't be 6. So this is 7. So this has to be 4 and 8. So this is 6. This is 2, 3. So this is 4. No 7. No 7. No 4. So 5 and 9 is there. 2, 3, 6. 2, 3, 6. So one of these is 9. Well, we already knew that, though. So this is low. And we have another low. And one of them was low. So this cannot be 2 or 3. So this is a high. So this is low. This is medium. This is high. This is medium. So this cannot be medium. This is high. This is medium. So this has to be 2, 3, and 7. We don't know which order. So this is yellow, yellow, yellow. So we have just pink and orange here. This is 5 or 6. We know one of these 3 is 5 or 6. We don't know which. So this is low. This is high. So this cannot be 6. Oh, we know one of these is 5. Then this cannot be 5, right? So again, if this was 5, it has to be next to an 8 and 9. If this is 5, so it can never be 6, right? If this is 6, this would have to be 8, and that doesn't work. If this is 6, it cannot be next to, this has to be 7 or 8, so that doesn't work. So 5 has to be here. And since this, if this is 5, that would have to be 1. This cannot be 5. So we know this one's high. So all the grays are highs. and all the dark colors are green. So then this has to be the 5. So this is 5. This can't be 5. So this is high, which makes this 8. Oops. Makes this 8. This is 4. This is 9. This is 5. So this has to be 2 now. So this cannot be 2. This can't be 2. This has to be 2. Three and 7. This has to be 9 now. So this cannot be 9. This is 5 or 6. This is 4 or 8. This could be... Wait, this has to be 6. Right, so this is 6. So we have what? 3, 5, 7, 8. This is 3, 5, 7, 8. So 5 and 8 are here. So this can't be 8. This can't be 8. Therefore, this has to be an 8. So this can't be 8. So this is high. And this is 3 middles. We have 1. Okay, so this is 3, 4, and 7. Oops. 3, 4, and 7. So this can't be 4. Therefore, this has to be the 4, which means this is green. So this is blue or red. This is blue or red. This is 1, 3, 7, 8. No 3 or 7, no 1 or 8. This is 3 or 7. So these are 3 or 7. This is 1 and 8. 4, 5, 6. This becomes... So this can't be 2. This can't be 2. This has to be one of these, has to be 2. This can't be 4. So it's 2, 3, 4, 6, 7. This is 1, 2, 3, no 4, 5, 6, and 7. So it cannot, so yellow cannot be high because 8 cannot be here, 8 cannot be here, 8 cannot be here, and this is a set of 3. So yellow also is medium or low, which means pink or purple, whichever one, has to be the high. So this is 9. Since this is 9, this has to be 5. This cannot be... Okay, well, yeah. Yellow cannot be... So this is 7, 8, or 9. Can't be 8, so this is 7 or 9. This is 1 or 4. If this is 4, this would have to be a 2 or a 3, and that does not work. So this cannot be 4. This has to be a 1. So yellows are all the yellows are essentially blue. And all the oranges are green. So then this is 6. This is 3. This has to be 6. This is 3. This can't be 1. This has to be low. So this is 2, and this is 1. So this has to be 6. And this is 2. No 3. No 2, 6. No 2. This has to be 5. Because it's green. And this has to be 8 or 9. So this cannot be 7. So this is 9. This is 6, 4, and 5. This is 3, 7, 3, 7. So this is 6. Can't be 1. This has to be 8. And this has to be 2. So this is 9 again. This cannot be 8. This cannot be 5. So we have 3, 7, 3, 7. This has to be 8 then. This is 8. This is 5. So we have 4, 7, and 8. So this can't be 4. This can't be 7. This is 1, 4, 8. So this can't. This is 4. This is 8. This is 1. This is 8. So it's 7, 4, 7, 3, 3, 7, 3, 7, 3, 7, 3. This is 1, 4, and 7. Interesting. I like the rule set. It's very, very interesting. It's the typical entropic line, but it has an extra constraint, which forces more restrictions on the puzzle. And I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.